Welcome to Study Loop.
We are told that a pilot who experiences more than 4 Gs of acceleration begins to gray out, or in other words, lose consciousness. Assuming constant acceleration, we want to find the shortest time that a jet pilot, starting from rest, can take to reach Mach 4, or in other words, 4 times the speed of sound. The speed of sound is 331 meters per second. 4 times the speed of sound is 1,324 meters per second. And g, we know, is 9.81 meters per second squared. That's just the acceleration on the surface of the Earth. So we want to find the shortest time that a jet pilot starting from rest needs to reach Mach 4. So we know that acceleration is just the change in velocity divided by time. Our initial velocity, in this case, is 0 since we're starting from rest. And our final velocity is going to be 4 times the speed of sound. We know any change in anything is always final minus initial. So we have 1,324 minus 0 divided by t. And we want to set this actually equal to 4 times g. We want our acceleration to be 4 times little g. 4 times little g is 39.24. So let's set a to 39.24. Simplifying, this gives 1,324 divided by 39.24. Which is an answer of 33.7 seconds. The shortest time they need to get up to Mach 4 is 33.7 seconds. Okay, so that's part A. Now part B, you want to figure out, given this time and given this acceleration, how far would the plane travel during this period? So the formula for position as a function of time is given by this. The final position is the initial position, called xi, plus the initial velocity times time plus acceleration times t squared divided by 2. Parentheses on this to make it a little bit more clear. So we're solving for xf. Our initial position we can just say was 0, so we can always choose our starting point to be 0. Our initial velocity is also 0 since it starts from rest. And our acceleration is going to be equal to 4g. And remember, 4 times g, well, let's just keep this in variables. So then our final position equation just reduces to a times t squared divided by 2. Our a in this case was 4g. And 4 times 9.81 is again 39.24. Our t was 33.7. Plugging this into a calculator. we get final position, or the distance it travels, to 3 significant figures. Since the speed of sound was only given to 3 significant figures, is equal to 22,300 meters.